Okay, so today we're going to go over cost behavior, chapter 6. We'll go over the PowerPoint slides, although I'll do them just like I do in class, except rather than writing it all out, I'll go ahead and use a spreadsheet. And it might move a little faster than what we do in the classroom, but the good news is that you'll be able to stop and rewind and get what you need to get. So first thing we're going to move to is slide number 4, cost behavior. And so in essence what we're talking about with cost behavior is that, in other words, depending on certain circumstances, they will either move in certain ways and that's what helps us to predict things. So when we talk about cost behavior, what we mean is how costs change as volume changes. So in other words, we're trying to predict how costs will change based upon volume changes. And when we're talking about volume, we're talking about production. So in other words, if production goes up, then production in terms of volumes or quantities that we're producing, then we will look at the costs and see what costs and how they change relative to those changes in volumes. All right, and so like I mentioned before in the classroom, in many cases we're trying to find a way to simplify things so that we can predict things. Well, I mean, if you make it real complicated, you'll try to create matrices that will predict the future of certain costs. But if you just essentially can find a way to group most costs in a certain manner and group them into predictable manners, then it makes it easier to predict the future. So the most common cost behaviors include, that's my bullet point, I guess, variable costs, fixed costs, and mixed costs. Okay. So the first thing we'll talk about is variable costs. All right. So we'll put variable costs up here. And what we're talking about with variable costs is defined by the way the textbook points it out. Variable costs are costs that are incurred for every unit of volume. So in other words, every time you produce a new product, a new item, whatever you're producing, whether you're a printed circuit board or maybe tubing, some plastic. Let's say we look at these. Let's say we manufacture these mouse. We produce mouse. Every time we produce another one, the costs will go up or they'll change, and they change in direct proportion to the volumes. Okay. So what we're looking about is total variable costs change in direct proportion to changes in volume. So let's say we double the production of this mouse, or mouses. If we're talking about these, if plural, it's not mice. You would think it is, but it's not. If you double the production of the mouses, then you would expect that your variable costs are going to double as well. All right. So variable costs change in direct proportion to the changes in volumes. Let's see. So when we're looking at graphs always begin at the origin. So if I draw a graph here, so there's my graph, right? And we're looking at dollar amounts on the y-axis, and the x-axis is parallel. If we talk our x-axis as being the quantity, so here's kind of like what you would see on the graph. And since the quantity would be 0, then your starting point always on the graph will be right at 0. Okay, so right at 0. So graphs always begin at the origin when you're plotting variable costs. Always begin at 0. And then from there, the slope represents the variable costs per unit of activity. So, you know, as your quantity increases, you would expect the variable costs will go up. So as an example, I can't draw it real time, but if I just draw like a graph representing variable costs, we would expect it to go up something like this, where essentially you start off at 0, and as the quantity increases, your variable costs are going to go up, right, in terms of dollars. So I'll call this line the variable costs. Variable costs. So there's your variable cost line. That make sense? I think so. So okay, so we have the graph. So this would be dollar amounts, and then the bottom line would be the quantity. And so we know that this would be 0. If we got 0, there's nothing here. Let's say we put on this end 5. All right, oops. That would be left justified, so we'll go 5, whatever number of units. All right, so this is 0, this is 5 in terms of quantity. I guess we can move that over. And then let's see, we'll use the drawings. We're going to insert a shape. How about we do that? We'll do lines. There you go. So you could see if this represents variable costs, we'll just put the abbreviation BC. Variable costs, you have a graph like that. Okay. So at 0 quantity, you have no dollar amounts, but at 5, your costs are going to be, let's say this is $30,000. Say somewhere in here, let's say that's $15,000. So somewhere about here, you know, your costs are going to be 15, but when you get to about right here, it'll be more like 30. All right. All right, so we're going to use an equation. We'll use a cost equation to express and predict costs, right? And when we're talking about variable costs, we can come up with a pretty simple equation, which in fact you're actually familiar with it, I'm sure already with it, if you've been familiar with it because of your algebra class. Yeah, I think your algebra class actually has maybe algebra 2, I'm not sure, but you have a linear equation. And then we can take a look at a cost equation, and it's going to be specifically for variable costs. So the first cost, what we're talking about with the cost equation, we're talking about a mathematical equation for a straight line to express how a cost behaves. So how a cost behaves. So this is going to be like for a slope type equation that you probably remember when you took algebra, but we're talking about the variable cost line. The variable cost will be y equals vx, v times x, where y, we're talking about y equals the total cost, total variable costs. All right, so then v, let's go ahead and change this. What does v equal? V becomes variable cost per unit. And then what you might already be figuring out is that, okay, well then in that case, then the x must be equal to the volume of activity. Or, we could look at it as the quantity, okay? Now, there's an assumption here, and the assumption is that variable cost per unit remains constant. So if we talk about variable costs, if we want like an example, let me put up a couple of an example here. Let's go back up here to variable costs. Costs that are incurred for every unit of volume, total variable costs change in direct proportion. So some examples you might think of is, okay, when we talk about the three elements that we've talked about direct labor. And so for the most part, if you think about the direct labor, we're talking about people that are working on the line, that are actually producing those parts. And so the more volume, the more direct labor costs you're going to have. So this would be a variable cost. Okay, there'd be no question, direct labor. Direct materials. Well, same thought process. The more volumes you have, the more materials you're going to have. So that's also going to be considered a variable cost. The trick is factory overhead. So factory overhead, some example, they're going to be made up of both variable and fixed. So for example, variable costs, example would be like repairs and utilities would be a good one, right? Yeah, utilities. As production goes up, you could expect your utilities to be higher because those machines are consuming more juice, right? So utilities would definitely be, you could also expect repairs and maintenance. Repairs and maintenance, as your machines are moving and producing more, then your maintenance is going to kick up, repairs are going to kick up. So that would also be a variable cost. And these are all part of factory overhead, right? And then, let's see, what other variable costs might we maybe supplies, indirect supplies, or indirect materials. Let's do that, indirect materials. So from factory overhead, the VC, the variable cost examples would be utilities, repairs and maintenance, indirect materials. Those all would also go in line with variable costs. Okay, so just so that you remember though, factory overhead will also have some elements of fixed, but for now we've just identified just the factory overhead that we can look at that is likely going to be variable. Okay, all right. Now we'll go down to fixed costs. These are costs that do not change in total despite changes in volume. So some examples, those specific examples here, we'll go ahead and put our asterisk here, specific example. How about property taxes and insurance? Property taxes and insurance. What else could we could look at? Depreciation. Another fixed cost would be lease payments. And then another fixed cost would be salaries. And you could see the trend here where essentially these costs, the property taxes, no matter what your volumes are, if you produce 30,000 units or you produce 10,000 units, your property taxes are going to be the same. Insurance, likely going to be the same. Depreciation, that's something that's determined when you buy the asset and then you're depreciating it over its useful life. That's not going to change. That doesn't go based upon volumes. It stays pretty static, right? Lease payments, those are rent payments. Salaries, managers, those again, they're fixed. They don't change relative. They don't change relative to the number of units that are produced. They stay pretty constant. So property taxes, insurance, depreciation, lease payments, salary payments, those are all fixed in nature. All right. Let's say we have what's called committed fixed costs. And committed fixed costs really just mean there's really no choice on those. I mean, they're already committed. And an example would be, let's say the rent on a facility, on a building that you've signed a 3-year contract, for example. Well, there's not much you could do about that. It is what it is. You're just going to have to pay that rent, and it's committed. Those costs are committed. So and they're fixed in nature because your rent doesn't change based on volumes. For the most part, they don't. But they're committed. You could have what are called also discretionary fixed costs. Those are tougher to find. But essentially what you're saying are these are costs that are discretionary. We have some leeway. They're still fixed in nature, but we do have some discretion. In other words, we could stop it if we really wanted. That one's a tough, but let's say as an example, you had a piece of equipment that you use in the back, and you're leasing that piece of equipment, and it's actually helping you with certain elements. Maybe it's making it easier for your employees to do the job, but the fact of the matter is that maybe it's discretionary in nature. In other words, you could do the job without it. You just do it because it makes your life easier, or makes life easier for the employees. But you might consider that to be discretionary because you have choices with that. You could or couldn't go with it. It's discretionary in nature. And then we have like when we're looking at the graph and we're trying to explain that, that's going to be more of a flat line that intersects the y-axis. Because it's fixed in nature, it doesn't start off at 0 is where I was going to get at. So this is going to be not variable now, this is going to be fixed in nature. Your volumes go up, even if you go from 0 to 5, let's say this is more like 500 now. Maybe 5,000? I don't know. Anyway, it doesn't really matter. Whatever those volumes are, even if they move up, and your cost is going to be remaining the same. If I go back up and change this to 500, that actually brings a little bit more light to it. Okay? So that's what we're looking at. We're going to scroll down here. We're going to look at the fixed costs are fixed in nature. They don't change. And so therefore, you have a straight line associated with it. Okay, so there's a picture in your PowerPoints on slide 11. Okay, so now we're going to look at the cost equation. So cost equation, fixed costs, this is just essentially the fixed cost. Well, this is going to be an even easier equation. Y equals F, right? Well, that's pretty simple. What does that mean? Well, Y is the total cost, and F, what is F? F is the fixed amount over a period of time. Now, here's what's kind of interesting, and it'll be relevant when we're talking about some other things later on in this chapter. We're looking at it from this perspective. The fixed cost per unit is inversely proportionate to volume. So, in other words, as the volume goes up, as the volume increases, then your fixed costs per unit, not in total. In total, it's fixed. We know that. $15,000 lease payments every month is $15,000 a month, period. That doesn't change per month, right? But the fixed costs per unit will actually fall as volumes pick up. And if you think about it, it makes perfect sense, because if you have a fixed cost, let's say 15,000 units, and you only produce one unit, right? One unit, boom. That's all. That one unit is going to get $15,000 of cost, of fixed costs associated with that one unit. But because the fixed costs are fixed in nature, let's say in that same element, you're going to go ahead. Let's say you produce 3 units. 3 units. You have 3 units. The total cost is $15,000. Well, the cost per unit now, that $15,000 is going to be allocated to the 3 units. So each unit is going to get $5,000. So per unit, your cost actually went down. The cost per unit went down because you had more units. The total cost is the same, total cost is fixed, but the cost per unit goes down.